So for the last section, we're going to do something called implicit differentiation. What we've been doing the whole time is called explicit differentiation. But since it's what we do most often, it's just easier to say differentiate. And then when we get to these weird ones, we're going to call it implicit. Bottom line is that we're going to take derivatives of things that are not functions. Okay, so let's review for 1 second. A function is a graph that will pass the vertical line test. Okay, so if I draw a whole bunch of vertical lines, these vertical lines can only hit my graph one time. And that's why every time that we've taken a derivative, we can evaluate it at an x value. The issue, and this is the graph of a circle, okay? So I've got a circle and its radius is 3. X squared plus y squared plus radius squared. So this is 3, this is negative 3, this is 3, this is negative 3. Well, now when I do the vertical line test, it actually crosses my circle in 2 different places, which means this x value will spit out 2 different y values. Okay, so this will be, I don't know, 2 and then whatever it is, 2 and some number, and then 2 and some negative number. Okay, so a single y value will spit out, a single x value will spit out 2 y values. So what we're going to do with implicit differentiation is it's a whole lot easier to do implicit with things that are not functions than it is to do explicit. So I'm going to show you the long way first. So if I were to take this derivative, first of all, I would need to get it into a y equals format. Okay, so I'm going to subtract x squared from both sides. So that gives me 9 minus x squared. Well, I don't care what y squared is, I care what y is. So I'm going to take the square root of both sides, and that gives me y equals plus or minus the square root of 9 minus x squared. Now, the positive root is this part, okay? That's the positive root. The negative root is this part, okay? It's the part underneath. So if I want to take a derivative, this is where it gets messy, okay? My derivative will be, because remember I can write this as plus or minus 9 minus x squared to the 1/2 power, okay? And my pen just died. Dead pen. All right. So 9 minus x squared to the 1/2 power. Okay, so this positive, negative, I'm working 2 problems at the same time. One of them is the positive, one of them is the negative. But since they're the same equation, it's just one positive, one negative, I'm just going to write it at the same time. All right, so my derivative is going to be, drop your exponent out front, 9 minus x squared to the negative 1/2 times the derivative of the inside, which is a negative 2x. Okay, so this flips, this negative will flip those. Okay, so in other words, this is nasty. Okay, and it can get really, really messy. So here's what we're going to do with implicit differentiation. I am going to rewrite my equation. It was x squared plus y squared equals 9. With implicit differentiation, we are going to solve for dy dx. Okay, we're going to solve for dy dx. Now, here's what that means. I am just going to leave this thing as it is. Whenever I take the derivative of x, I'm going to multiply it by dx. So in other words, I'm going to take its derivative and say, look, I took its derivative. So this thing becomes a 2x dx. Okay, so I take the derivative and then I note that I took the derivative of x. Okay, same thing for your y's. So I take the derivative, which is going to be a 2y, and then I note that I took the derivative. So instead of me saying y prime or f prime of x, I'm actually just using a different notation. Okay, the derivative of 9 is 0. So the first step is you differentiate. The second step is get your dy's on the left and your dx's on the right. So your dy's go to the left, your dx's go to the right. And just something for comprehension purposes, this is the derivative of y. This is not d times y. This is a number. It is a single number, okay? So here's what I'm going to do. This has a dx, and he's on the wrong side, so I'm going to subtract him over to the right. So by subtracting him, I now have 2y dy equals negative 2x dx. So I've got my dy's on the left, I've got my dx's on the right. The next thing you want to do is get rid of anything in front of the dy. Okay, so this says 2y times dy, so I need to divide by 2y. So I now have dy equals your 2's reduce, negative x over y dx. Okay, your last step is going to be get rid of your dx. Well, how is it connected? It's multiplication. So divide both sides by dx, which means what you have is dy dx is a negative x over y. So notice that you have now incorporated a y variable into your derivative. So go back to the fact that this was a circle. If this is a circle and I give you an x value, you've got to choose which y value it is. Okay? So now instead of me saying, well, you've got the point, let's not use that. We've got the point 1 comma root 8. Okay? Now I've told you which point it is. That's why we've always had the y coordinate along the ride. Well, now you're going to use it. Okay? So your derivative at the point of 1 comma root 8 is the same thing as the slope of the tangent line. So now I can shove a 1 in here. So I get a negative 1 over the square root of 8. That's the slope of that tangent line. So this process, you were done differentiating in one step. You just had to solve for dy dx. And that is a whole lot cleaner than you going through this mess and then taking a derivative. Okay, so again, let's formalize your steps. First step is you're going to differentiate. Okay, the next thing is wherever there's an x, you're going to note that you took its derivative by multiplying by dx. Dx can be a number, okay? So you'll have x, and then you'll have the derivative of x. Okay, wherever you have a y, you're going to put a dy. Okay, wherever you differentiate them, don't just start slapping crap all over the place. Okay, then third step, so you've taken derivatives. Now you want to get your dy's on the left, and you want to get your dx's on the right. Okay, and then from there, you're going to solve for dy dx. So you'll have to do some addition, multiplication, whatever. So you want dy over dx on the left, and then your formula will be on the right. Okay, so again, differentiate. Wherever you take a derivative of x, multiply it by dx. Wherever you take a derivative of y, multiply it by dy. Okay, make sure that you organize by putting your dy's on the left and your dx's on the right. And then you want to solve for dy dx. So just like up here, the very last thing I did was divided by dx. So I got dy dx is a negative x over y. Okay, so the way you read that is dy dx. You don't say dy over dx. It's implied that it's over. So just dy dx is negative x over y. All right, so next video we're going to practice.